Hey there guys, welcome back to another video with me, Ben Rogashawn, aka the Seattle Data Guy. Today we're going to talk about Docker. Now, many of you probably have heard the term or, of the technology, Docker. I really want to give a background on what Docker is, why it's important to data engineers, and also, give a few examples or a quick tutorial on how you can set up a basic Docker container. So let's start with the probably more obvious question, which is, do data engineers need to know what Docker is? All right, because there's so much technology we need to know, so do we need to know what Docker is? The short answer, like everything else in technology, is yes and no. And let me explain that slightly longer now, before you get too upset. What I mean to say is you could spend your entire data career and never, ever run into a Docker situation where you actually have to use it. It's 100% possible. There's so many different ways you can set up your infrastructure, as well as teams, to where it could be a different team that manages it all together, that you may never work with Docker. On the flip side, if you work for a startup or you decide to go more of the data platform route, where you're not more of a data engineer in the traditional sense, but you are a data platform engineer, so the person that actually manages the platform, then Docker will likely be something you run into. Or Kubernetes, but that's a different video. For this video, we're just talking about Docker. So the short answer is kind of yes. It's good to know. It's good to understand. It's good to grasp why and what it does. Like why it's important, what it does. Those are important concepts. Will you maybe never have to run like a Docker compose or a Docker run command? Maybe. But that's kind of the short of it. Some specific examples where a data engineer might actually use Docker are things like possibly you set up your entire data platform where it's set up in either Kubernetes or some sort of Helm chart or some way where you've got multiple components, Data Hub, Airbyte, Airflow. So let's dive into, first of all, what Docker is and why it's important. For those of you who don't know, Docker basically allows you to take all of these dependencies and all of this code and all of these things that you want to often deploy into some sort of piece of software and do it smoothly. Now, many of you might not know what that means in terms of maybe you lived in a world where Docker's always existed. I have sadly had to live in a world where, in order to deploy code, you have to do things like put together release notes, put together instructions on how to deploy said code and go step by step through, not just saying, hey, here's code, deal with it. You actually just talk to an operations team who then took that code and made it work in real life, basically, right? Yeah, it's great that you've made it work in development. Now let the professionals take over and actually make it work in operations. And in that process, there's all these connections to databases and all these other systems that you rely on that could just be nicely packaged in some form of Docker or Docker compose file, which we'll kind of get to the difference there eventually. So that's what we're kind of trying to get rid of. We're trying to get rid of the old-fashioned approach, which many of us have had to do, where in order to deploy essentially a new piece of software, rather than having to zip it up, have a configuration file kind of tagged in there. You have to go through all these steps in order to actually get the code ready to be in production. Instead, all of that can just be in your Docker container. All of your dependencies, especially if you're used to Python, it's just your requirements txt file. That is now just a basic run command in your Docker file, where it's just run pip install, requirements.txt, etc. So it's very simple, honestly. You give it the exact instructions and know that in theory, it should run the same way on your computer compared to other computers. Unless you recently got the M1 chip and it was a year and a half ago and you tried running a Docker container and quickly found out that M1 chips were not developed with Docker in mind, or vice versa. Docker hadn't taken that into consideration just yet. Now you can actually download the M1 chip version of Docker. We'll talk about that here in a second. But that's kind of what Docker is. It's making the deployment of code and all of the things that it depends on, again, configuration files, databases, nicely packaged into a single set of files. So instead of, again, you having to do a lot of manual discussion with your ops team, it's a much quicker process. Okay, so that's kind of generally what Docker does. That's not really what Docker is. What Docker essentially does is it is a platform that allows you to take advantage, similar to virtualization, although not, essentially create a virtualized OS. Traditionally, virtualization was done at the hypervisor level, but we've now kind of taken that up essentially one step. And Docker essentially leverages the host operating system, so the thing that essentially just connects and that communicates with the kernel, And by essentially, again, skipping the step of needing all this other stuff, standard virtualization, you have a far faster kind of setup time. Like when you spin up Docker, it doesn't take minutes. It's basically up. Once you say, Docker run, it's running. Honestly, if you want a better, again, quick story, when I first started in the world of technology, virtual machines were like everything. Everyone was like, we're doing everything in virtual machines. It's amazing. It's great. One of the things that I always notice is that in theory, they were always supposed to run in their own isolated kind of system. So, right, like the hardware or the virtualization, the software was, in theory, supposed to like take like whatever, 32 gigs of RAM, and you split it between two things. And in theory, they shouldn't touch each other. But because they are often physically connected, they're on the same hardware, they still would cause issues when you'd run like a large process on one, the other one would actually be impacted, even though supposedly that wasn't supposed to happen. I saw it happen all the time. More just fun stories. Okay, so that's basically what Docker is, right? Like it's kind of connected to virtualization, slightly different. Of course, people out there who actually do system admin work and are very deep in the technical work would get upset that there's even a comparison. But that's kind of an easy way of thinking about it. Okay, and if you're a data engineer, there are lots of times that you need Docker to run things. Docker, for example, plays probably a role when you're spinning up Airflow, although you're likely using Kubernetes, in getting everything set up, right? Because you want to create a system that can spin up the workers, has a scheduler set up, has a web server set up, has all those things maybe even in different pods. That way they either don't impact each other or can kind of scale up and down as they need to. And all this stuff, again, gets very complicated. And personally, if you're going to ever spin up Airflow yourself, I'd recommend talking to a DevOps person first, because I've just seen too many ways that Airflow is set up poorly. Okay, before diving into Docker, we're going to go through a few commands. I want to go through a few of them now. That way, as I'm explaining them, you kind of know what I'm talking about. The most basic command that is somewhat self-explanatory is docker run, which is essentially kind of what it sounds like. It's going to be the command that runs your container that's based off of an image that you have essentially built. Next, one that I use very kind of frequently, it's almost like ls, is docker ps and usually -a. I just add in the -a anyways because I want more information. This will essentially list out all the Docker containers that are running currently and their state. And I'll constantly use this, especially to see if a Docker container has failed. And if it's failed, then I'll use Docker logs. Again, then you got to reference the actual Docker container number or ID, and then see like why did it fail. Next, you'll see me often use docker exec it, then the name of the actual instance, followed by bash. And this is basically what I use to access the Docker container. So this is essentially, you can think about it almost like SSHing into a different server, except for that server lives on your computer and doesn't have as many cool things on it. The one thing that just makes me think of every time I do set up Docker, I forget that it has like nothing on it. So I'll always like essentially exec into it, and I'll try to like Vim, and nothing works. And then you realize, oh yeah, I don't have Vim or Nano or anything downloaded onto this Docker container. The other command you're going to see me use is docker compose up, docker compose down, and docker volume prune. Actually, I might not use the prune one, but these essentially commands are for when you have a docker compose file. So the docker compose up command basically lets you start and restart the services that are in your docker compose YAML file, whereas the docker compose down command, kind of as it suggests, takes down, removes all the containers that are running, whereas the docker compose down command stops essentially all of the containers that are running and essentially removes any like networks or other stuff that you've been set up when you ran the docker compose up command. Then usually you'll have to do docker volume prune, which just gets rid of everything officially. You don't have anything left. There's no images that maybe you've got built that kind of get all swept away. And so that's kind of the process that I'll usually do when I'm doing a complete wipe away of something just doesn't seem to be working. So those are the commands you're going to see me use. There's obviously a whole list of other ones. I'm going to put them here, but those are some great commands that you should know. All right, let's dive into the actual video. But to show you a baseline example, let's just go through one simple way you can set up a Docker file to run, in this case, just a basic Flask app. So let's just go through that example. Okay, so first step for anyone out there who's just getting started, what you're going to need to do is download Docker. Now, if you're on a Mac, there are multiple ways you can do it. I'm just going to say, you can use the download Docker desktop approach. That's the way I like. Again, you're going to have to hit Apple chip and then download if you have the M1, and if not, you have Intel chip. So whichever one you have, again, I have Apple chip, so it caused a lot of issues when I first tried to spin up Kubernetes again. All right, so we've got that downloaded. In theory, it's technically already running. So we're going to look at my Finder. I have two of them. And what I've got here is this Docker file. So let me open that up, actually. All right, so we've got this Docker file here. And what you'll see is this first command here will pull down an image. So there's something called Docker Hub, where there's a bunch of pre-built images. You can go on there, you can scroll. They're essentially already pre-built, and basically it'll pull that down when you run it. And that it uses it kind of like the base, right? Like you can almost think this is building the foundation. So I'm pulling in this one. Next, it kind of sets this working directory, which I've called app. And then we're going to basically, in that working directory, put these copper requirements.txt file. So this is basically setting up what things are going to look like. Because when you actually spin this up, you're going to have essentially a, again, virtualized system you can not log into. That's the wrong word. I think a term I've heard people use is essentially mount. But you can just go into essentially almost like your SSHing into like an EC2 instance or another server. So we'll show you that here in a second. From there, it'll run this pip install command. And from there, it'll run this pip install command. We're going to expose 80, the port, because we're going to actually use this to build just a basic app.py kind of Flask app. And then from there, again, we're going to run this Python app.py file. And so that's really it. So I'm going to spin this up here in a second, and then we're going to connect. We're going to show you what it does, both how we can go into it, but also, kind of how it, like the whole Flask app works. All right, so I'm in that Docker demo folder. Basically, if I were to run like Docker PS, which should list what currently exists in terms of containers, there's nothing there. Then if we do Docker images, again, nothing is there because I haven't built anything yet. So, and if we do Docker images, same thing, I haven't built anything yet. So both Docker containers, Docker images, blank. I'm going to run this Docker build command and then give it this name here, which is this Flask Docker example. You'll kind of see it run through the various commands here. So it literally will, finish all 11. So what you'll basically see, so if you run through these commands, is these are all the commands that we've got. So the copy.app, etc., all these things were run. But if I were to go through this again, Docker PS, nothing is in containers yet. But if I go Docker images, there is an image there. And there's kind of a distinction, right? The image is essentially just the template of how something is going to work, and you haven't actually deployed it yet. You actually now need to run it, essentially, right? Like that's what Docker run is. Deploy is not the right word. You haven't really started to run it. And so nothing's really running. It's there, it's ready to start, but it's not running. Now, if I say essentially Docker run, we're gonna run this command, Docker run, etc. Should, hopefully, fingers crossed, this should work. Pretty simple. Cool. So it's running. You kind of see it's running right here. It's saying, hey, if you go to this location, essentially localhost. Actually, I think it should be this one. Never tried this other one. You could probably try localhost or this. So now you can see it's essentially running. So the port is essentially open on, but like we've ported it over to 4000. So I actually need to go to localhost 4000. So if we go to this, it'll say, hello, this is the Docker Flask app, essentially. So we've got it running, essentially. So we've built this up. We've all set it up. The one thing here is like you'll see that it's logging in my terminal, which is maybe something you don't want. So in order to kind of get around that, instead of doing it that way, what you might do here is say -d, which is basically to say run it detached. So if you want to avoid essentially having all those logs, essentially, which is kind of cool to see, you can see yourself go to the website, you see yourself come out, you can hit docker -d-p. So D stands for detached, so it's once it's running. So it's running. Basically, this is the ID. So when I go again to this local host 4000, you'll notice that it's not, there's nothing running here. And so that's basically Docker. Now there are a couple other commands that you will see. For example, you'll see Docker compose. And like I said, there are a lot of other commands you can use. And the Flask example might not even be one that some of you use, because some of you might be, not interested in building Flask, but many of you will likely want to work with something like Airflow. So I did want to go through an Airflow example. And with Airflow, we're going to use a different command, like I referenced. We're going to use Docker compose. And basically what Docker Compose does is kind of like it suggests, it allows you to spin up multiple like things that are going on, essentially. Like multiple components, essentially. Things, great word. Multiple components. So we're going to use Postgres, Airflow Web Server, and Airflow Scheduler, and we're going to have all of that running, and the Docker Compose file is going to set that up, and you can literally set it up so that like you have one service run, there we go, there's the word I'm looking for, one service run, another service run, and another service run in a specific order, which is going to be important with Airflow, because if you run it out of order, the scheduler won't work, or if you're trying to point to the Postgres instance and the Postgres instance isn't up yet, that won't work. So let's kind of go over that here really quick. So with Docker Compose, you put together a Docker Compose file, and it's different, obviously, than what you're typically used to, but it's got some similarities. So you're going to call it the image again. So if you recall in the prior example, you had the from. This is kind of similar. You're going to call it the image that you want to pull in. So again, this is, if you go to Docker Hub, you can find this specific setup already. So this Postgres. You'll set up some environmental variables. And then from there, we're setting up Airflow Web Server. So that's this next one, and then Airflow Scheduler. And what you'll see is there's a few other important commands here, or at least, sorry, a few other important configurations, such as the depends on section here, and then also here as well. So this has to run in a specific order to make sure that everything runs, everything actually works. If not, what ends up happening is Airflow Scheduler will run, or Airflow Web Server will try running, and not everything will be there, and then it'll kind of freak out. You also have this command here that I've set up just so you already have a user set up on your Airflow instance, and then same thing here. I'm just running Airflow Scheduler to start when we start. So it's pretty straightforward again. It's kind of like the prior example, except now we just do 3 different services rather than just one, and that's going to kind of be the approach. So here, again, we've got some new commands. It's pretty simple. In this case, it's just going to be Docker Compose up. There's also Docker Compose down. And then if you're trying to get rid of that image, essentially, and then if you're trying to get rid of that volume, essentially, you can just kind of use Docker volume prune. But we're going to do Docker Compose up, and we're going to see a lot of things happen all at once. So you see everything kind of running. Postgres getting set up. Airflow Scheduler is getting set up. Airflow Web Server is trying to start. Okay, Airflow Scheduler set up. Okay. Now I don't think it's finished setting up just yet, if I recall. Okay. So in theory, I think I can go to localhost now. Let's check. Okay, so it's running. And again, I put the password as admin and admin. And you'll see Airflow is running here. We've got it running. If you don't have this running correctly, up here, what you'll see is a yellow thing that says, hey, Airflow Scheduler is not running. But you see, it's here, it's running, we're good. So this is how you've set up Airflow. Obviously, some things I want to point out in that Docker Compose file, because someone's going to yell at me in the comments. So let's pull this up. I forgot to call these out. Executor here. Local executor is fine if you're doing it locally for testing. If you want this in production, this will not work. You will want something different. This local executor will not function correctly. You're going to want to use something like Celery Executor. The other thing you don't see here is like, and I've called this out before, or at least in some articles, you don't see where the logs are going. So in this case, the logs are being stored locally. In fact, I can probably show you that. So if we go in here, logs will be stored in this folder essentially, which is not good in production if you're storing it on if you're storing it just on some local location that is like an EC2 instance. That EC2 instance will explode eventually. Maybe it runs for 6 months, maybe it runs for 12 months. It depends on how big your logs are and how big your EC2 instance is. But eventually that location will explode. Or you have to make sure you've got some sort of deletion function or something going on. The best thing to do is usually dump it into S3 or CloudWatch or whatever you're working on to make sure those logs don't break what you're on. So yeah, there's a lot of little things in production that you want to change here, but this is again a local version, and it'll work, and it's great, and it'll work. So that's really Docker Compose. Again, we've just added it so there are more layers essentially now. So now instead of just having that one instance with this basic Docker file, we now have multiple services going on. So that's kind of it. And again, we could actually like log into these different services if we wanted to. And then again, we could mount, and then again, we could, essentially connect to these different services if we wanted to, and like connect to this Postgres instance. We're not doing that today. This is just a basic example. Hopefully that's clear. Honestly, for the longest time, I just didn't Google what it was. I kind of understood that like when you wanted to have more things spun up, you want to have a more complex, essentially Docker file, except for now it's a Docker Compose file, you would use Docker Compose. And it's kind of obvious what it means. It really just means kind of what it sounds like, which is like you're trying to compose a bunch more things. So this is actually something you'll see very commonly with like, let's say a basic Airflow setup, that you need a Docker Compose file because you've got things like Postgres that you're likely setting up to manage kind of the actual metadata of your Airflow instance. You likely have a log location that you might be setting up in there. Actually, recently, I had a Airflow setup with a client where we even got to pre-configure a bunch of files and environmental variables and all of this other stuff prior to even loading, essentially, as we're building everything up. So I thought that was really cool, things that I just hadn't seen. Again, for me, my Docker skills are good enough to work with, but I'd say there's definitely people who are far better. If you haven't ever seen, I think it's Tech with Nana. So honestly, if you want a better, deeper dive, there's no actual ad here. Tech World with Nana, I've watched her stuff, and every time I'm like looking for more information and I want to get a deeper understanding, that's where I go. Like DevOps in general, that's where to go. There's a reason she almost has 900,000 subscribers. Her videos are on point. But anyways, guys, thanks so much for watching this video. I really appreciate your time. And if you're a data engineer out there looking for Docker, hopefully this was helpful. If not, let me know what other things you'd want to see. I'm happy to give you more. Other than that, guys, thank you so much for watching, and I will see you in the next one. Thanks and goodbye.